Hi everyone, this week I set out to build this LED stoplet that I can fix at the back of my bike. The goals were very simple. There should not be many wires. It should be expandable so that I can attach more components if required. Everything must be weatherproof. This stoplet has the Atmega328 IC as its brain. The Atmega chip uses 5 volt and all the automotive electronics runs of 12 volts. So I have used these transistors to level out. There are also these 3 switches which imitate the different signals. This one is the stop signal which changes the animation. This one is a turn signal towards the left and this one is a turn signal towards the right. If you want to see how I made this, stick around. First making the LED strip and animating it. When I sat down to think how to make them, multiplexing was the best option. But what is multiplexing? In a layman's term, it's a way to control a lot of LEDs with just a few wires. Let me explain with an example. I want to control all these 16 LEDs and this can be done with only one shift register. How? By turning them into a 4x4 matrix. All these intersections are one LED, so a total of 16 LEDs are here. In fact, I came up with the number 16 because of this matrix. In each row the anodes are connected and in each column the cathodes are connected. So when I supply 1 on the first row and 0 on the first column, this LED will light up. And this we can change into a byte value like this. 1 here, 0, 0, 0. Again we need a 0 here and then the rest all will be 1. So this is a byte value. So in the same way, if I want this one to be lightened up, then I have to set this as 1 and then set this as 0. So the byte value for that will be, this one has to be 0, 1, the rest are 0, 0, and then this one will be 1. This one has to be set to ground, so 0, and the rest two are 1, 1. So the respective byte value will be this one. Let's again put this in a row format to see how the connections will be made. So according to the connection in the matrix, all the anodes in each group are connected together. Let me do that first. Because the circuit runs off 5 volt, a 220 ohm resistor is a must for the LED to light up. Because at any point of time only one LED will be light up, this setup should be enough. For the cathode, the first LED from the first row is connected to the first LED from the second row and so on and so forth. The same goes for the second LED, third and fourth. So let me go ahead and just draw it. Now we have 4 anode connections and 4 cathode connections, and a shift register has 8 output pins. A shift register can be set to 1 or 0 using a microcontroller. So let's start wiring this up on a breadboard. So here's the breadboard design. All the LEDs are connected according to the schematics that I showed you before. All the anodes are connected together and all the cathodes from the first LED to the first LED of the second group and so forth are connected together. Here the plus 5 volt and ground comes to the breadboard and the data, latch and clock pin are connected to the 74HC595. Now to the programming. Here is a simple program. Above, the bytes define the animation. The first 4 numbers define the value for the anode and the last 4 numbers are for the cathode. Then in the loop, I increment the index value here and using the shift out method, I send the data to the shift register. A point to note is that I've used LSB here so that the animation runs from left to right. If I have used MSB, then the animation would run from right to left, but in that case, the cathode has to come first and the anode has to come after that. For the bike stoplight, I have simply expanded on the same program with different animations. Then using a simple if-else statement, I have checked which switch is pressed and show that animation. In the byte animation, I have simply set each LED to high by setting their respective anode and cathode high and low. This program will check if all LEDs work, and here you can see them lighting one after the other. Speaking of switches, as I mentioned before, we have to level out the 12 volt input to 5 volts so that we can feed it into the Arduino for the Atmega 328 chip. We can use voltage divider, but the automotive power is never 12 volts. It may increase or decrease depending upon the charge level of the battery. Luckily, there's a voltage level diagram given. Here they used BC547 transistor. I just followed the schematics and wired this up. Instead of the constant 5 volt, I used some voltage divider using the 220 ohm resistor and 330 ohm resistor. This gives roughly about 3.5 volts, and I just use this for better circuit protection. Finally, I connected all the switches to the analog input over here to the Arduino. Normally when the power is on, this animation keeps happening, so that when we switch on the bike, this animation will by default will happen. When I press the stop switch, the immediate change in light indicates that the bike is going to come to a stop. And then here's another animation to signify that bike is going to turn in that direction. Using the Eagle Cat, I designed the board. I tried to make the design as small as possible, so I created the board design with SMD. For the control board, I have designed this Atmega328 chip board. I call it the bike brain because it has space to add more switches and outputs. There are 3 more switch terminals provided, and they are leveled out and connected to the rest of the analog pins. So all the analog pins are connected to switches and all the digital pins are considered as outputs. Then I etched them using toner transfer method. Please click here if you want to see how I etch PCBs. Then drill some holes using homemade mini drill press. Finally, here it is. I designed a case for the LED lights. It is sealed with hot glue to prevent water entering the case. For the control board, I decided to tuck it inside the toolbox to see if that will work against the water. If not, I will make an enclosure for that too. I did not want to complicate things with long wires and sourcing power from the controller board, so kept things simple with each board having its own 5 volt voltage regulator. Please follow me on Instagram at MrJCRP to see how this goes on my bike. Please tag me on social media as #MediaMillan if you make this. If you have any questions, please leave them in the comments. Until next time, happy learning!